So, am I on? Yeah, it sounds like I'm on. According to my clock, it's time, so let's get going. Welcome to Will Your Program Still Be Correct Next Year? Or How to Prevent Evolution from Taking the Wrong Turns. I am Björn Fahller. This talk is that there are many ways that you can prevent your program from taking the wrong turns over time. This talk is about testing specifically. So like I said, I'm Björn Fahller. I live in Stockholm. I work for Net Insight. We make networking equipment like these things. Plethora of CPUs in these. Every plug-in board has at least 2 CPUs on them and a couple of FPGAs typically. This is what I tend to do in my daytime. Let's get going. An example. I'm going to use this example throughout the entire presentation. So I want to have a histogram of words, a simple thing. So I want to be able to insert words into the histogram, remove words, query the number of occurrences of a word with the bracket operator. And I want to be able to traverse all the words in the histogram with begin end, so it behaves like a range. So, and I'm implementing this in terms of a stud map. So, insert. I can do a try and place to see if it was inserted. If it wasn't inserted, that means it was already there. So, I increment the count. Right? Straightforward. Remove. I look up the word. I say that if the word is not there, it's a bug, so I assert on it. If it was there, I decrement the count. If the count becomes 0, I remove it from the map. So that seems straightforward. And the angle bracket operator, look up the word. If it's not there, return 0. Otherwise, return whatever the count is. And begin end, we can just forward those to the underlying map. So this seems good, but of course, we know through experience that even simple code like this, it doesn't work unless we test it. That's just the way it is. We need to test it. So I write a test. I have my main program. I create a histogram. I insert a few words, print the entire histogram, remove a couple of words, print the entire histogram again, and try to see how often do we have foo, how many instances of foo and how many instances of baz. So run this, and I can see a result. We can see foo is there twice because I inserted foo 2 times. That makes sense. Bar is there once. We inserted bar once. Baz once. Yeah, okay. Good so far. Remove baz and foo, and we are left with 1 bar and 1 foo. And baz is completely gone. Yeah, that looks good. Yeah. And then we see how many foos are there. There are 1 that, yeah, that is what it should be. And there are no bazes. Okay, good. So, and I also, just by printing the entire histogram, I have exercised begin and end. So, good. Nailed it. This is good. Or, I mean, I have tested it. It's correct, right? This is an exhaustive test. It's good. But yeah, no one will know if a future change introduces a bug because no one's going to run that test again and go through all the results. So maybe that was not a good way of writing a test. So maybe we should do something a little bit different. Let's do it this way. Now we have a test that automatically tells us if it's good or bad. So I insert the same words again, but I say that this is the expected result, and I assert that we get the expected result. And again, remove the words, check the result that it is the correct one with an assert, and the same for the angle bracket or for the indexing operators. And I run this and it passes. So yeah, again, nailed it. Now I have an automatic test that anyone can run. If they make a change, they can run this program and it will either bomb on an assert or it will pass. So, yay. Good. So let's look at a few types of tests. There are many tests. This is just something that I wrote on top of my head without thinking too much about it. But like unit tests, stability tests, stress tests, fuzz tests, acceptance tests, etc. There are many more. And of course, depending on where you work, you have different names for the same things. That's the way it is. But we can look at some of the types of tests and what they're for. I would argue that fuzz tests are definitely about finding bugs. Ad hoc tests, manually fiddling with this stuff. It's sort of like doing fuzz testing, but with manual labor. Acceptance tests, verify compliance with the requirements. Are we shipping the thing we should ship? Production tests. I work at a company that develops hardware, and the factory wants production tests. Unit tests show that the code does what it's intended to do. Performance tests ensure that performance requirements are met, or even if you don't have performance requirements, follow up your performance so that you can see if you have degradations, if that is important. Stability tests. Does your program still work after having working continuously for 2 weeks? You'd be surprised. Integration test. If you're a large company, many teams working together, you can use these integration tests to learn that, oh, your teams, you thought you did the same thing, but you didn't actually. You misunderstood something. Stress test. Give the system more to do than it can handle. Are you ditching the right things? How do you behave? Or do you just lie down and die? Smoke test. Stop wasting time. So who is the receiver of the result of these different tests? The first test, definitely the developer. Ad hoc tests, the team or several teams maybe. Acceptance tests, definitely the teams and the product lead and the customer. Production tests are for factories. Unit tests, definitely for the individual developer. Performance tests for the team, but it's also for the product lead. Even if you don't maybe have exact requirements, but they can tell the marketing people that we know that we can handle these because we have measured it, we tested it. Stability test, definitely for the team. Integration test for the plural teams. Stress test, plural teams. Smoke test, teams. And also, when these tests fails, what is the desired outcome of a failure? So for fuzz test, it's discovering missed cases. There is some corner case you missed and the fuzzer found it. Good. Ad hoc tests, pretty much the same, but it's also that something is functionally a bit weird. Like 1970s car electronics, where if you brake hard while turning on the windscreen wiper, the horn starts beeping. The 70s car electronics were weird. Acceptance test to identify misunderstood or missed requirements so that you don't ship the wrong thing. Production tests prevent shipping of defective products. It's finding a bad soldering or a broken component. A curious thing with production tests is that you usually don't care very much about error pinpointing. It's just, it's good or it's not good. Unit tests, understand what is broken. Performance tests, they identify bottlenecks so that you can do something about them. Stability tests, find memory leaks or cumulative errors. You'd be surprised with cumulative errors. Something that you have a slight rounding error that just grows and grows and grows over time, and after 40 hours, your program starts misbehaving. Those are fun. Integration tests, identify these misunderstandings between teams and developers. Stress test, find modeling errors, seeing that you're not throwing away the right type of work. The system starts misbehaving if you give it too much to do. Smoke tests, we use them a lot. We have in the lab very, very long test suites that they take many hours to run. So we have a smoke test as a pre-test to see that, yeah, it boots, we can do some basic stuff. It's not obviously totally broken, so we can go on. Like I said, unit tests, they are to understand what is broken, but I argue that these tests share properties in terms of what we want to get out of them. So my reflection on this is that these tests say what is not working as expected. And to do that, they better say what is expected. So what's wrong with this that I wrote? It's an automated test. It will give you a crash or a pass. But if an assert fails, you have some detective work to do to understand what actually is the problem. Why is this a problem? What should happen here? It doesn't communicate what is expected. It just says it isn't what is expected, whatever that is. So, yeah, write your tests as a set of requirements, saying that during these circumstances, when you do that, this should happen. It's a boom, boom, boom. Actually, I should rephrase that because I hate using the word should in tests. Should is wishy-washy. It's does or does not. So a failed test will then always tell you what doesn't work, and let the failure message explain how the problem was found. So let's do a small but not insignificant improvement. So still just have my main program. I print a description of what I want to test. I posit that a default constructed histogram has no words. I created histogram. I assert that begin and end are the same. And if it's not, the program breaks there. Otherwise, it prints pass and it goes to the next test. And so on. So if we run this, we can see an example of a failure. What is wrong? When a word is inserted, it has a ref count of 1 with operator index. And how was the problem found? Well, a certain h of foo equals 1 failed. So we have already an improvement. We don't have a heck of a lot of detail. What we know exactly that the bug must be in either the insert function or the angle bracket lookup function. It's one of those. There are no alternatives. And we can see that just from the message it gives us. We don't need to go into a debugger and analyze anything and try to figure out through the code flow what must be true. However, please don't do it like that. You use some testing framework. These are some I found through a quick web search. I'm sure there are others. I know that there are also commercial tools if you, for whatever reason, are unable to use open source in your workplace. So let's improve this. I'm starting with one of those that I showed called doc test. So a word of advice, not absolutely necessary, but in your test sources, start with including the header of the thing you want to test, because this way you are certain that the header stands on its own merits. There are no hidden dependencies that you have forgotten. If you do have that, this won't compile. Doc test is very simple to get started with. It's just a single header file, include doctest.h. And if you define this doctest config implement with main, then it actually creates a main function for you, so you don't even have to bother with that. So it's very easy to get started with. Test cases are written with this test underscore case and a free text description of what the test is. And then you have a function body. Require is the word that you use to assert that this must be true. And you can have, of course, you have a set of several tests. So if we run this, you can see an example of a failure, and we can see what is wrong. Well, when a word is inserted, it has a ref count of 1 with operator index. And how was the problem found? Well, require h of foo equals 1 is not correct. It expands to require 0 equal 1. We have more information already now than we had before. Plus, it's much easier to see because it actually runs all the tests. It doesn't abort execution on the first failure. So, vast improvement. Use a unit testing framework. Let's do some more. We need to be able to query the number of words in the histogram. That's a reasonable thing to ask. So we can create a size function and why not an empty function? That makes sense to ask, are there any words at all or not? Yeah, we can do that, and we can add some tests. A default constructed histogram has no words. We already had that test, but I'm expanding it a little bit here now. And this makes a lot of people cringe. Because a test should only test one thing. A lot of people take this as saying a test should have one single assert. I'm not going to die on that hill. I don't really care. Personally, I'm fine with this because I think that this is one thing. I have several ways of checking that one thing, but it's still one thing. But some people absolutely say, no, you must not do that. You must have 3 tests for this. If they say so, I'm going to sigh, but I'm not going to fight. So we had some more tests. Adding words affects size. Given a histogram with 2 unique words, the size is 2. That makes sense. Adding a word that already exists, the size remains 2. Okay, that makes sense. And we have adding a new word, etc., etc. This style, BDD style, given when then, is, in my opinion, it's super powerful. Where you have a common starting point and you have some variations on it. You do a few things. So instead of repeating the same thing in several test cases, you just have these variations. However, beware the temptation to just add one more and then it is so easy to just add another case and another case and another case, and suddenly you have a test case that is 2,500 lines long and no one can follow it. Don't restrain yourself. Have 3 or 4 variations around a common starting point. That is fine. Don't let this grow too much. This is not a technical problem. This is a human problem with how we work, our minds work. So be aware of that. But given this, an example of a failure will then be, so what is wrong? Adding a word's effect size. Given a histogram with 2 words, 2 unique words, adding a new word, the size becomes 3. That is what's wrong. That is what doesn't work. How was it found? Require h.size equals 3 is not correct. It expanded to 2 equals 3. Okay. We have information here directly in the error message that it seems like we have a bug in the insert function, probably, almost certainly. Interesting. This helps us quickly find what the problem is. So we do some more. We want to test the range behavior. So we say that a histogram is a range with all words and their reference counts. So we create a histogram, add some words to it, create something that we want to compare with, and then assert, require that ranges equal our histogram with the expected result. And a failure is not great. Require ranges equal h dot comma expected is not correct. Expands to require false. That's a bummer. So I'm changing to a new test framework, catch 2. Catch 2, well, obviously different headers. It behaves, simple tests in catch 2 and in doc test look exactly the same. Catch 2 has more. The downside is that build times with catch 2 are longer. An upside is that you have more abstractions to write things. So in this case, I'm using this range equals. So I can say require that h range equals expected. And when I run that, I get damned. Okay, so when catch 2 presents a value in a message, it uses, by default, it uses the stream insertion operator for your type, and there is none for stood pair. So it just writes this question mark when it doesn't know how to represent them. That is a bit of a bummer. Now, do resist the temptation of, okay, I'll just add an O-stream insertion operator for stood pair. Don't do that. That is not what you want. You want to be able to have your tests show your type. So catch 2 has this string maker template that you are encouraged to do specializations for. So we can write a string maker partially specialized on all pairs. And you then implement the convert function to get a string out of it. So in this case, I'm writing them as curly brace, the first element, comma, the second element, and curly, and return that as a string. So when we have that, we get this. Now we can actually see what the problem was. I have no clue why Baz got a wrong count, but I have good information right there in the message from the test framework. So that is great. So we have more expressive tests, more information from a failure in the test. So we live on. This histogram is great. It's used a lot in our programs, but we need to improve performance. Apparently, people use this with tens of thousands of strings. So the map is not great in this case. So we can change this to use an unordered map instead. And I've chosen to have my own hasher here, the transparent hasher, so based on the hash of string view. So the lookups on the unordered map works with string view, with char star, with std string, anything that can become a string view. So that is good. And when we run it, we see, actually, come to think of it, that makes sense, doesn't it? It's the implementation of begin and end were just forwarded to the maps begin and end, and there is absolutely nothing that says the order of an unordered map. That didn't make sense to say, did it? Are the same as in a std map. So the problem here is that the test is over-constrained. It tests that the words in the histogram, when seen as a range, are in a specific order, but there is nothing in the description of how the histogram works that says that this is what you should expect. It doesn't say that there is any specific order at all. It just says you get the words. And in fact, that is even what the title of name of the test says. It doesn't say in alphabetical order. So we can make a tiny change. Catch 2 has this unordered range equals. Now it says H must have all of these elements, no more, no less, exactly these, but we don't care about the order. And that is actually what it should have been in the beginning. But it's an easy mistake to make. So don't beat yourself over making that mistake. I certainly have made worse. But when you find this kind of over-constraining, don't adapt the test to over-constrain again, but for the new thing, try to think, how can I generalize it so that in this case, the order doesn't matter? And now everything passes, so good. Yes, so new requirements. We need to insert and remove words separated by a substring. Okay, that makes sense. So we can have like A, B, C, and we insert A, B, and C separated by the comma. Yeah. So we can have functions insert the string and the separator, and also remove the string and the separator. Yeah, seems to make sense. It's easy to see that we probably want something that does the separation and does some action when for each word it finds. So I can write this this function. It's a private function because it's nobody's business how we do this. So we loop while there are still words. We find the first word. We call the action on the word. We see if we have reached the end. Otherwise, we remove the prefix, go back to the loop, and go one more word, one more word, one more word. And this I mean, it's good. We can see insert becomes really simple. Called per word with the string and the separator, and this lambda that calls insert for each of the words. So that is great. But how do I test this per word function? It's a private function. This is one of those things that took forever for me to understand, because what usually tended to happen was me, junior developer, asking, how do I test private functions? And the senior developer says, you don't. And I said, but surely there is a lot of really elaborate functionality in here. This needs to be tested. I said, yes, it does. So how do I test private functions? You don't. Man! But here's a trick, a really cunning trick. We don't. As the senior developer said, we don't. We break this logic out into something freestanding. We test it separately, and we make it a private matter that we use it. So yeah, freestanding per word. Actually, now that it's freestanding, maybe this name is not great. We can change that. For each word, that is a better name. And now I can write tests for this, because it's a freestanding function, or actually a function template in disguise because of the auto there for action. So I can write action is called on each substring between separators. So create a vector of substrings, call for each word with a, comma, c, d, comma, e, f, g, and the separator is a comma. And the lambda that pushes each word back on this substrings vector. And then we require that the result substrings range equals an array with a, comma, c, d, comma, e, f, g. And here it is range equals, not unordered equals. We really want to see that they are called in the right order. And then we add some more. Action is called on the whole string if separator is not found. If the string ends on separator, an empty string will be the last. If string begins on separator, an empty string will be the first. Adjoining separators yields empty strings. Action is never called if the separator is an empty string. Action is never called if the string of words is empty. All right. This is enormously powerful because now the intended functionality of for each word is easy to see for everyone who just reads the title of each test. So if you have the function signature and you just read these names, you know exactly what to expect of it. And it is tested on every build. So if you make a change to the implementation, if you screw up, it will be found. This is enormously good. So now we can write our insert as calling for each word. And here's where this presentation is not as good as I would have liked it to be. So what happens here is you now have to write a test for histogram that covers what is interesting in the view of the functionality of histogram. You don't have to test every corner case for each word. But say, for example, if I had a better example, there was a function here that returned some enum type with enum A, enum B, enum C. I need to test the logic that I cover all those returns, A, B, and C. But I don't need to test every way of getting these values, because that is tested elsewhere in the freestanding test for the freestanding function. So this is an improvement. It makes life easier. So then you go about browsing CPP reference as one does, and stumble upon this split view. Split view takes a view and a delimiter and splits the view into subranges on the delimiter. This sounds suspiciously familiar. I wonder if maybe we can make a simplification here. It seems like we should be able to do this. For auto character range in std view split, words on separator, call action with the string view of each character range. This is a lot easier to understand. I like this. Good refactoring. Except, okay, damn. What's wrong? For each word does nothing if separator is an empty string, okay. Substring we should get a substring that is empty, but we got A, B, C, D, E. All right, so this split view says if the separator is nothing, then you get each individual element, in this case of the string. Interesting, okay. Missed that corner case, but that is not difficult to fix. We just say if separator is empty, return, don't do anything. So Now everything passes and tests saved the day. So could have shipped a bug there. Could have shipped a bug there. Okay. So we move on. We have this contract. I mentioned this earlier. That we have this assert that remove requires that the word actually is in the histogram. How do I test an assert? That is kind of nasty. So one thing you can do, another test framework, Google Test, include gtest.h, and Google Test has a different syntax for tests. The macro is uppercase test, and the name of test suite and a name of the individual test case in that suite. Google Test expands these to be actual names of functions, so these have to be usable as identifiers. So the formatting becomes a little bit ugly, but it's readable. You can deal with this. But the really interesting thing is that Google Test has what they morbidly call death tests, where we say that when you do this, it must die. The program must die here. And it does this by spawning a child process. On the Unix-like system, it calls fork. How on earth it does this on Windows, I don't know. But it does, somehow. So here I can say that assert exit, calling remove banana when there is no banana in the histogram. The program must be killed by signal sigabort. So I run this, and I seem to have a bug. Remove non-existing word is illegal. Program died, but not with the expected exit code. Terminate by signal 11. Zigzag. Okay, that was a surprise. I find this Google Test functionality with death tests, they're useful, but they are extremely blunt. They don't tell you so much about where things happened and so on. But you do get a functionality that you, to my knowledge, don't get with any other test framework. So that is good. But we can do this in a different way. Yeah. The mock word. Because that is definitely one way. So I must spend a minute or two on mocking, especially since I happen to be the author of a C++ mocking framework. Yeah, read the t-shirt. It's interesting how divisive the idea of mocks is among developers. There is a very vocal group that says mocks are the stupidest thing people have ever thought of. If you use mocks, you clearly don't know what you're doing. You're an idiot. You should never do that. Never ever. And of course, you have another group of people that says, "What do you mean? Of course you use mocks. How else do you test things?" And I can speak from my own personal experience. Going back, say, 10 years or so, I used mocks a lot. The past 5 years, from 5 years ago until last year, roughly, I didn't use a single mock at all. Nothing. And the last year, I have started using mocks again. So does this mean that I didn't really used to know what I was doing way back when, and then I saw the light, and then I lost all my marbles and didn't understand how to do things again? No. I wrote completely different types of software. Use the right tool for the right problem. For some problems, mocking really is the stupidest thing you can do. For some problems, it makes perfect sense. Should we use mocks here? We could have a mock for the replace the assert by calling something that we can mock. Personally, I don't think we should do that here. I should mention that even though I like using mocks when they make sense, I also think that people tend to overuse them terribly and making both the test code and the tested code much more difficult to work with. So use them when they bring you an advantage and don't otherwise. In this case, you could, but I don't think it would add anything other than a lot of extra lines of code. So what I think I prefer to do is to have, I have a misnamed this. This should be a violation handler. That is what it should be called. Not a precondition. It's a violation handler. Do a mental substitution. So I have a violation handler P that is a default handler. The default handler does call abort, but you can replace it with something else. As the name implies, the violation handler P defaults to the default handler. And I'm using just a simple function pointer here. You could use something else. And we can change this code to say that if we didn't find the word, call the violation handler. All right? So how can I test this? Well, I'm back to catch2 again. I create a local type here, test exception. This type exists only in this test code, nowhere else. And I call remove banana with a replacement. Instead of the default handler, I could call it with my own a lambda. Did you know that unary plus on lambda is on a capture-less lambda is a thing? Not a lot of hands. So for those who did not raise their hand, a capture-less lambda can be used as a function pointer, and having the plus sign in front of it forces that decay. You learn something new. One more useless character that is actually not useless. So now we call remove banana with something that throws a test exception, and test exception exists only in the scope of this test. And catch2 has this require throws as, so it says this thing must throw, and it must throw an instance of test exception. So if I run this, I can, for example, get removing a non-existing word is illegal. I have a problem there. How was it found? Because no exception was thrown. Okay, so something is wrong there. This is a perfectly adequate technique, in my opinion, to test these untestable things. So how about this one? If we remove several words, what is a reasonable way to test this? Because maybe I remove the same word several times, and the first two succeed and the last didn't. Is that a good functionality, or is that a problem? It's worth thinking about. I think this is also one of those things that took a long time for me to get an opinion about. I think that if it's difficult to express a test case for something, then it's often a hint. It's not a law by any means, but it's an indication that maybe something is problematic with your design. Maybe you shouldn't have it this way. So in this case, maybe the problem is that the API is just wrong. It shouldn't be this way. A possible change would be to, instead of saying that it's illegal to remove a word that isn't there, we just returned how much was removed. So we can say that the remove function says it returns 0 if the word wasn't there, and it returns 1 otherwise, and then of course the remove with the string view just accumulates everything and returns what we got there. So then I can write some new tests here. Removing a word not in the histogram, 0 is returned. Removing a word in the histogram, 1 is returned. Removing multiple semicolon separated words, blah, blah, blah. So that is one way of doing it, and we can see an example of a failure that something is wrong. The number of existing words that were removed is returned. Number removed equals 2, but we got 3? Okay, interesting. Alternatively, maybe this whole API extension was a mistake. Maybe we shouldn't have done that. Maybe we should just drop these and let the caller do the looping and decide what they want to do. So look, here's a really useful function that someone can use for each word. Oh my. So this is what the user code can do. And that now we have forward the decision, the policy of what to do to the user of the histogram instead of the histogram mandating a policy upon the user. Is this the right way to go or not? Well, it's a design decision. It depends. What do you feel like? What does your colleagues feel like? What kind of problem are you actually working on? Does this make better sense or worse sense? It depends. But it's a different way of doing things. But as it happens, for each word is an available function. It is well documented. It is well tested. So maybe. So it's time to wrap up a little bit. So in my opinion, a good test tells you what's wrong by telling you what right would be. So you have a clear indication of what should have happened and what went wrong. A good test works as documentation that is automatically verified every single time you build. A good test suite is a set of very simple tests. Don't write these monster tests that are several hundred lines long. Very convoluted logic. Try to keep them simple. Many, but simple. Each test is simple. Because you want to feel certain that the test itself is correct. You don't write tests for your tests. If the test is simple enough to be immediately understood, then it's not really a problem. Have many of them. Listen to your code. If it's difficult to express a test in your code, maybe your code is trying to tell you that you're doing the wrong thing. Maybe your design is problematic. It may not be. It may be that the problem domain you're working with is actually difficult. I've been doing video encoding lately, and damn, that is hard. The video guys are crazy. Beware of dogmas. There are a lot of dogmas in tests. It's like, you shall only have one assert, as I mentioned, per test. You must do this, you must do that, you must never do this. And I sod that. Though many of them can serve as good guidelines. Listen to them, be inspired by them. Don't follow them dogmatically, but see that, okay, there is a kernel of truth here. I should think about what I'm doing. Also, a bad test is superior to no test. So don't sweat it. I can take as an example last year I made a change to code that I wrote in, I believe it was 2008, I'm not sure, thereabout. The tests for that code is horrible. It violated absolutely everything I talked about today. Absolutely everything. But I made a mistake in my change. I broke something, and the test suite caught that. Since it was a bad test, it took a lot of time for me to figure out what on earth I had broken, actually. But it did catch that I broke something. It did prevent me from shipping a bug. So, sure, strive for good tests, but hey, a bad test is better than not having a test. Except flaky tests. And by flaky tests, I mean tests that usually passes, but once in a while they don't. Because what happens when you have flaky tests is that you just know, okay, it failed, I just rerun it, it works. And then you get tired of the auto builds failing randomly, so you mark the test as may fail, which means that from that moment on, no one looks at the result of that test anymore, ever. And now someone makes a mistake, something that is actually always caught by that flaky test, because it's a logic error, it's not something weird. But no one notices, because may fail, who cares? So don't do that, don't ever accept flaky tests. Fix them, or you might as well remove them, because when you have marked them as may fail, they are morally removed, even though they are physically there. And software tends to evolve for a heck of a much longer time than you think. And the next person who makes a change to the software is someone who is not familiar with it, because this software has been dormant for 5 years, 10 years. And suddenly there is a requirement to change it. And no one, even in the case that the people who wrote it are still at the company, they don't remember. But most probably someone who doesn't know. So a way of helping those developers, who might be you in a year or two, to feel safe in making the changes that they need to do. Tests help a lot. I want to give some recommendations. Kevin Henny did a workshop here earlier about exactly this, good unit tests. So who was there? A few of you. I watched a version of, he has done many presentations on this theme. GUTS means good unit tests, by the way, if you didn't know. The first one I watched was one from a Java conference. I think these things are programming language agnostic. I will not lie, when I watched that, it completely changed my view on how to write tests. And I have stolen so much from him in today's talk. So this is great. I absolutely watch some version of Programming with GUTS by Kevin Henny. Those of you who were at his workshop, do you agree? Was it good? No one dare say anything. Okay, never mind. I cut that from YouTube. Phil Nash did a really interesting talk that is not really about writing tests per se. It's about test-driven development. I haven't talked about TDD at all. I talked about the tests themselves. But this is a good and interesting talk, and I think that personally I try to use TDD. Normally I sometimes don't, but typically I try to, because TDD means that you never even enter these traps where it's really difficult to test, because you try to express how I test something before I implement it. And I think his ideas there are really good. So strong recommendation. Also, Arne did a talk was it last year or 2 years ago here at this conference? Properties of unit tests in C++, where he had a lot of things to think about, recommendations, advice. Strive for doing this, try to avoid doing that. Definitely worth watching if you weren't here for his talk a couple of years ago. And that is it. That is what I wanted to say. Thank you very much for your kind attention. Yes.
Versus pitfalls about performance. You change the implementation in which you believe